This is geometry. We're talking about area of sectors. A sector is one slice of pizza. It's a pretty big slice, but it has to do with the central angle, and using that's going to be proportional with the 360 as the area of the sector is to the whole area of the full circle. So to calculate these, it'll be very similar to arc length was. It's the area of the sector over pi r squared. That is part of the circle's area over the entire circle's area, which is going to be equal to the arc measure, which is the same thing as the central angle, over 360. Very similar to the arc measure. Here we have the central angle over 360 equals the sector area over pi r squared. 63 is our central angle. 360 is the entire area. So the relationship 63 has with 360 is the same thing, this sector area, so we call it sector RQS. We don't draw an arc over it because it's not an arc measure. It's a sector, almost like a triangle, over pi r squared. We notice our r is 5, so we square that. Now we only have to cross multiply in one direction. So this is 63 times 25, because that's 5 squared, 25 pi. That is still divided by 360, and that should equal the sector of RSQ. That is sector area. So we'll take our calculator, and we'll do 63 times our 25 pi, and we're dividing that by 360. That gives us 13.74. Those are going to just be units. We don't know what units we're using. So those are square units. And this is your sector of RQS. Okay, for the second one, you can probably go ahead and try this one out. Look at what we have. We have an angle value, and that's of the shaded sector. So the angle has to match the sector that we're working with. If they give you an angle of another part of the circle, you need to calculate the part for the sector you're calculating. It has to be the sector's central angle. So, just as a reminder, it's the angle over 360. The sector area is the gray part that we're looking for. And that's going to be related to the entire area. An area of a circle is pi r squared. So we take 106 divided by 360, and we compare that to the sector RQS over pi r squared, and the r is 9. Now you can probably pause the video and calculate the rest of this out. We would cross multiply. That's 106. 9 squared is 81, so it's 81 pi. That's still divided by 360. And this is going to give us the sector area. So we're going to take 106 times 9 squared, which is 81, times our pi. And we're dividing that by 360. You should try typing this in your calculator to be sure you understand where all the buttons are and what makes a difference. So remember, area is always talking about square units. So since we're using feet in this problem, we're going to have feet squared when we talk about area. That implies that there would be 74 little boxes all inside our sector here if we had a 106-degree angle with a 9-foot radius. On the flip side, we're going to find the indicated measure. In each of these cases, there is an A given, and that A is the area of the shaded region. So we want to know what the area is of the entire circle. So thinking about how could we do that? If we had the radius, we could calculate the area of the circle. Oh, I don't have the radius. Well, this is about a sector, so I know I have a formula that is the area, actually the angle over 360 equals the sector area over the circle area. And hey, that's what we're trying to find, the circle area. So we're going to be solving for this portion of our proportion, this part of our proportion. So 58 over 360 equals our sector area. They give us the sector area as 3607. Now, I could write down pi r squared, but we're just looking for the area of the circle, so I could call that A. I'm looking at that as a whole value. So because the variable is on bottom, it's necessary for me to come up and multiply it with the 58. I also need to multiply the 360 with the 3607. So this gives me 58 times A and 360 times 3607. Then I'll divide by 58. And that's going to give me my area. This is the area of the full circle. I'm expecting the full circle to be more than the sectors. And because this is relatively small angle, it's going to be considerably more, probably 6 times that much. Let's find out. So we're going to take 360 times 3607, and we're dividing that by 58. And we get 223.88. And these are centimeters squared. If the area of the sector was centimeters squared, the area of the circle would be in that same units. Now, this next one is a little bit different. First of all, we're looking for a diameter. We want to know the distance all the way across. So I'll know the distance all the way across if I knew the radius, but I don't know the radius. If I knew the area and could solve for r, then I could get my radius. So that's what we need to do. We need to take our formula and solve for r. Notice the information they give us. They say that the A is the shaded region. But the angle they give us is not the shaded region. They need to match. We don't want the angle for over here, but the sector area of over here. So we need to match those up. So how do I figure out the angle? Call that a central angle if you want, or it's the measure of this large major arc. That's going to be 360, because that's the whole way around, not counting our 109. That's 251 degrees. That's going to be the arc measure. So we're going to do the arc measure, 251, over the entire circle, which is 360. The 72.39 over the entire pi r squared. So, because your unknown is on bottom, we have to cross multiply in both directions. That gives us 251 times pi r squared. And that gives us 72.39 times 360. So we're going to take our 72.39 and times that to 360. And then we're going to divide that by, we have to use parentheses, 251 pi. We're going to divide it by 251 pi because over here we're going to take our 251 pi and divide that out on both sides. So now we're left with just the r squared. And that's 3305. Notice that this is r squared. This is the radius squared. We just want the radius. So we need to find the square root of 3305. So we take our calculator and we do the square root of our answer. And that gives us 5.75. And that is our radius. Remember that a diameter is 2 times the radius, so we're going to do 2 times 5.75. So you could say times 2, because you're taking your previous answer, times 2, and that gives us 11.5. And these are going to be feet. It's not feet squared. It's just feet. All right. With this next one, we may get through parts of it. It's just doing another problem. Nothing new. No new rules. We know the area of the circle. The big circle is 295. So if we want to know the radius of the circle, I could use just that portion of it. The 295.52 is going to equal pi r squared. That would help me calculate what the radius is. And I type that into our calculator, and I get 94.07. And I have to take the square root of that number. So I want to take the square root of the answer. And that gives me 9 point, when I round up, that'll become a 7. So that gives me 9.7 0.70 as my radius. I found the radius of the circle. The circumference of this circle, remember, would be 2 pi r. So the circumference is taking your radius and timesing it by 2. 18, that'll be 19.4 pi. That would be your exact circumference. We would take our answer, times it by 2 pi, and that would give us 60.94. And again, those are in inches. So would this be inches, not squared, because it's not an area, it's a length. The measure of the arc, we have, which is our angle. We have our angle over circumference equals our arc length over, oops, I'm sorry, that's our circumference, over 360. So an arc measure is an angle, but the information they give us is the sector area. So we're actually going to have to use this formula that helps us calculate the sector area. We know the sector area is 55. We know that the area of the circle is 295. And we're trying to find the angle. So we're going to cross multiply to help us find this angle. And that gives us a 67-degree angle. Now to find the arc length, now we can come over here and plug this formula in here. We have a 60-degree angle. And our circumference is pi r squared. Well, we already know what our radius is. We found that earlier. That was the 9.7. Sorry, that would be 2 pi r, not pi r squared. That's area, silly. Okay, so we'll cross multiply to get 67 times our circumference. Well, our circumference we actually already knew was right here at 60.94 over 360. And that gives us 11.34. This is a length again, so it's just inches. So this is arc PQ.